whoops, bar, project. Awesome library. Okay, so these are the steps. You create a project, and I'm gonna do it in a new window, and then you create your Go file. You need to create your Go files at this point, your initial Go file. So let's just call this library, whoops, awesome library, right? And then you can actually create your mod file. Go mod init github.com Adrian awesome lib. You can see it's there now, boom. And then I need to enable integration. And then I turn off the proxy, because then if I use any private dependencies or anything like that, I'll actually be able to get them instead of going to Google CDN and then it not knowing where they are. This is not Java, this is Go. Mplaza. All right, so we got that, and now let's just write a function. We'll do it backwards. Instead of TDD, we'll do implementation, then test. So I'm gonna write known result, and this is just gonna return a string, and then we'll get a known result back here in the function by saying return known. Okay, extremely simple function. You can't get much more complex than that. Yes, there are people that stream. I don't know if I know anybody actually. There's a lot of C# streamers these days, but not any. I don't know any Java ones. However, I take that back. There are some people who stream Java. I wouldn't say that they're Java streamers. For example, I have written code in Java and streamed it, and I will be doing that some more. I'll be using some Spring Boot and doing things in the relative near future, probably in about 2 to 4 weeks, where I will be streaming Java code, which should be pretty cool. So if you're into that, definitely follow me here, subscribe on YouTube, on my channel there, and we'll do some Java stuff. Would I teach? Dr. Argus, this is the JetBrains IDE for Go. It's super badass. Love it. Tips when it comes to learning Java. I don't know what tips I could give you right at the moment about learning Java specifically. I learned Java as like my, I don't know, 10th programming language or something. I had been into a lot of other languages before I even got into Java. It's a really good first language, that's for sure. Writer for C#, yes, JetBrains Writer for C#, also badass. I have also streamed a lot of C# code with JetBrains Writer. Now I use IntelliJ for everything from writing Terraform for infrastructure as code, and I use it for the Java code that I do write whenever I write that. And I also use it for, let's see, your infrastructure code. Sometimes I even have used it for Go development. Kind of funny that, but yeah, it's good stuff. If other people can give tips on how to get the basics 100%, write code. Actually, that's my number one suggestion. Write code that breaks, write code with tests, figure out how to write tests for code. Yeah, Speaker Freak, on point there. Time in the saddle, writing the code. If you want to get fast, and if you've noticed how I just ripped through writing some of this code now, I've been writing Go for maybe a year or two, but I didn't even study it until about 6 or 7 months ago, maybe 8 months ago, something like that. But I'd used it for various things. But the reason I can go through it quickly is not because I read a book, not because I sat there and studied it, but because I've just written a ton of it now. Like the first year and a half that I was writing Go code, it was very fundamental stuff from like just kind of academic level stuff, and it took me a long time to write it because I didn't know the syntax, didn't really know how to structure it, didn't know how people wrote Go code, like what the practices were. But what I did was I started to get deeper and deeper into it because I needed implementation code around systems things like Kubernetes, Docker, etc. And I just had to write more code. So I just started implementing all sorts of different things, figuring out how to implement things like marshalling JSON objects, getting JSON in and out of things, starting to parse YAML files, configuration files, how to write CLIs, how to write concurrency stuff, those types of things. You write anything you can think of, anything. Literally start like, let's say with Java, just start writing something that takes data out of a text file or generates random data. That's a great thing that I usually start with. Yeah, I get in there and find a library. There's always a library in a language, Java, Python, JavaScript, whatever it is, and you can basically write a data generator, right? So you write a data generator that spits data out to a file. That's the first thing I would do with any language, and then start reading that data in and doing manipulations to it. If you have particular data that you want to look at or a particular domain that you're interested in, like let's say music sales or I don't know, airplane data or something like that, even better, because then you understand something about the data already. So write that out to files, read it in, start to process it, do things with it, and then take actions on it. Have it, print other stuff out. Yeah, so because really at the end of the day, what's a computer do? Processes data, prints stuff out so us humans can see it, right? So that would be my number one piece of advice with any language you're learning. Java, Rust, Python, Go, whatever it is. Generate data, spit out some files, like have it exported out to some format, whether it's JSON, YAML, XML, whatever you want. And then read that data in, use some of the parsers to read it in, and then do things with it. So yeah, hope that helps. I feel like I should write a whole blog entry on just like getting started and getting super fluent with a particular programming language. The other side effect of that is if you're parsing data out and then you read it back in and you do various things with it, you can go through a lot of the algorithms that people often give you when you're going through an interview. Because a lot of the interviews, especially for junior positions, the first thing they do is they give you a bunch of stupid algorithm tests. Like, oh yeah, here, write this test where it's going to take a string and it's a comma separated string and you need to separate out all that from that one string and turn it into an array and just have each item as an item in the array. It's ridiculously simple. But the thing is when you get it on a whiteboard and you start to try to write it out in front of a person on an interview, if you haven't done it 50,000 times, you'll probably mess it up. I mean, right now you're thinking like, oh, that's so simple. But then you try to do it under pressure and you mess it up. And then some interviewer is like, oh, I didn't know how to program even a comma separated list. It doesn't prove anything, but that's what the industry does. It's unfortunate. But when you've done it 1,000 times and all of a sudden you're like, oh yeah, whatevs, bro. And you have a comma separated list, you've spit it out, you like have the code compile and you just have it print out right there on the spot for them. Nobody can deny you just rocked that one. But you have to have done it 1,000,000 times to be able to do it on a whiteboard and have it work, to be able to think it through and just have it done, because you kind of have to have it in rote memory. Wait with reading a book. Yeah, I would say get a book. What I like to do personally is I like to get a book, like a physical book. I'm trying to see if I got one sitting around. I get a physical book where I can open it and bookmark it and everything, and I read just like a little bit. Like, let's say how to print stuff out. Like in Go, it's the commands are things like format.println. this is some text, right? Or text. And then there's another thing like format.printf. Printf is tricky, right? It took me a while to figure out what they were using. And when I realized what they were using, I was like, oh yeah, that makes sense. But like you say something like, this is a variable response, and then you print out the variable with a little thing that inserts it right into the string and interpolates it, and then you put the variable that I created here. Okay, and then up here you have var created, and let's say it's worth cheese, right? So now cheese would print out in that particular bit of code, right? Cool. Be sure to follow. I do this stuff all day long, every time I get on a Twitch stream, or I mess up the code and try to debug it for 20 minutes, which I was doing earlier because I was completely spacing on exactly what I did wrong. But yeah, always happy to offer suggestions, ideas, etc. So yeah, in this sense, we're writing a test, or we're going to write a test, and what you have to do in order, as we've just done, is you create a project, or like if you're just at a terminal, you just create a directory, you put a Go file in it, then you need to do the go mod init github.com/adrian/awesomelib, right? And then you create a little function, then create the test file, which in Go is awesomelib_test because it needs to end with test. There's that. And then one of the things about Golang that I love is you type func, control space, boom, you get your options. We're going to do test known result. And in here, we get a pointer to the testing library, which will give us behaviors to take with the test. And I'm going to get a result. What was it? Known result. And then we can check it. Result is not equal. We want to check not equal per Go practice. What was it? Known. And then we'll say T error. This is not the known result. Test failed. And then we can just run go test if you're using the CLI, which passes now. Or in Golang, you can click on the little play button here, and this runs the single test. If you click on the double play button, it runs all the tests in the file. And it also gives you the options to run with coverage, which shows you the full test coverage of everything, and with these other particular blocking memory mutexes, CPU profiler to see other characteristics of that particular test. So I'm just going to run the singular test. And there, you get a little bit of a different interface down here at the bottom that shows you that it passed and that it ran. The other characteristic in Go that you want to follow is kind of it always has to start with test if it's a test. Otherwise, Go doesn't know it's a test. And when you run Go test, it doesn't know what to pick up. So basically the two things are you start with test, and then the immediate following piece needs to be the function you are testing, or at least something like a capital letter, whatever variable you want to call it. So you could call it something like this test, that would still work, or whatever. But if you did this, lowercase, not going to work. So it needs to be, something like that. So we have our first test, that's working. But now, one of the things, by the way, hey Digital Drummer, how are you? It's always good to see you. One of the things about testing that's kind of, everybody's got their own flavors, how they want to do it. Sometimes they want to do TDD, sometimes they want to do BDD. TDD is test-driven development, BDD is behavioral-driven development. TDD, you test specific functionality at a time in units, thus the term unit testing. With BDD, behavior-driven development, you test more of functions that are written around behaviors of the system. So that's a little bit different of a paradigm. In both of those cases, though, you would write the test first, and then you write your implementation of the function. Okay? That's not always easy. It takes a lot of practice to get into that pattern of doing that. I never am able to do that when I first start with a language, largely because I'm like, I don't know what the testing thing is supposed to do. I don't know how the testing framework works, and I don't even know what half the functions or half the language does. So it always takes me some time. But I've been focusing lately on getting better at following a more test first then implement approach so that I think through my functionality when I'm writing Go. Because I'm pretty good at just coding up whatever. But a lot of the time, I want to stop and think, like, do I really need to implement this functionality? And if I write a test first and then implement the test, one, I've proven that it works. Two, I've thought it through. I'm not just like randomly coding stuff, because I can cowboy code all day long and end up with a whole pile of shit. Not always a good thing. So let's see here. If you want to do TDD though, one way you can do it is something like this. We'll do test new function, right? And then T, get that pointer in there to our lib. And then you can go ahead and do the implementation, right? So result, we'll call it new function. This is a very bad name, by the way. Not a good practice to call a function or a string or whatever. But this is purely for example purposes. You don't want to name things like this. You actually want to name the function what it does. So then I'll say if result is not equal to expectations. Then we'll say t.error. This test has failed expectations, right? So then, result. You can see the little underscored line here. And what Golang is going to tell you is that you clearly need this. It doesn't know where that function is. And the reason is the function doesn't exist. So there's a two-step process in Golang that I use at this point to do TDD in this example. One, I can use a shortcut key, get that menu again, which means I don't even have to touch the mouse. I can just do this real quick, hit that, and then I want to create a function for it. Boom, puts my function down there, gives me an interface result. I actually want to have a string, so there we go. I just hit enter again right after I typed in string, and it puts me down here to write the body of the function. So I'm going to write expectations, but I'm going to put a Z, right? One of the things with TDD is they often say, write a failing test and then make it pass. Well, in Go, it's kind of hard to write a failing test because you can't even get a build if you've written a failing test, right? Sometimes a language stack is in conflict with the intent of how to use a testing framework, or how to use testing practice, I should say. So in this particular case, got my new function. It returns expectations. And if I run this, I'm going to get a failing test. Boom. This test has failed expectations. That's actually what we expected. And that's not bad. But let's make it pass now. So we'll just actually change this because our expectations has a Z. But you know what? It's going to fuss about the typo because my IDE helps me spell words correctly, which it doesn't always know. Sometimes I have to add things to the dictionary. But I'm just going to go with a expectation, what it's referencing me to here, and then change that to expectation. Well, you can't make a class, but I get what you're saying. You can't, it makes it much harder to do TDD in the exacting practice. So you can build the stub, but that means you're basically still writing the function out. And what I'm showing here is, like, I hit that shortcut key, I got my function, I implemented that from the test. So you could still follow TDD from that practice. You just can't run it when it's broken, right? So you could stub it out, and I like to put false data in there just to make it fail, so then I can make it implement. Makes me think it through. Makes me think it through again, even though I've just thought it through. And I feel like I'm pretty confident those extra 2 steps, at least with my like ADHD dyslexic brain, it helps me fix where I often goof up and make little small mistakes. And by getting rid of those mistakes, it makes me like 300% more productive. So there we got those. And the other cool feature of GoLan right here is now with this, it should pass. And once I get it to pass, what I do is I often write my functions, and I do this with C# and I do this with Java too. I write my functions in the test file, and then I use the JetBrains refactoring to move them out of the test file to the place they need to be. But let's use some of that refactoring, right? So one thing we want to do is like best, no, actually, let's call it get some cool result. Okay, so that's kind of an actually a more better name, which is kind of a funny way to say that, but it is a little bit better than what I was doing at first, where it had function in the name. It describes what it's doing. It's giving you some cool result. So that, since that's a little bit better, let's move it over into where we actually want it stored. We're going to put it in the awesome.lib. And it's going to go into the awesome.lib file in the package awesome.lib. So this is the package up here, and then it moved it over here into the file. So we have both of these functions side by side now, and here's our test. Whew. So now I want to, yeah, more better name. It's definitely a more better name. I mean, it's not a more worse name. All right. Let's see here. Next things next. Okay, we want to do func test ignore these values. Pointer to testing T, and then boom, here we go, result. I just have not been able to type result lately. Filter, ignore list. And then I'm going to have, let's see here, list, ignore list. Okay, and then it's going to return a result of a list with the ignored items removed. Okay. Let's call this ignore these items. Okay, and let's say var list is going to be string something, and var ignore these items is also going to be a list of strings, and then let's say list is equal to, we'll turn it into a slice, so we'll say list first value, right? We'll put 4 values in there. So first value, second value, another value, and this thing. All right, and then in our ignore list, let's ignore 2 of those values. So ignore these items equals append. So ignore these items. Then we'll have, let's ignore the second value. Whoops, there we go. And then one more, we'll ignore this thing. So if we do that, and then, so based on our function, yep, 3 problems indeed. Naming, off by 1 errors. Had a lot of problems with that lately too. Naming nightmares. Oh. So yeah, all right, so we're filtering the ignore list, And basically what we want the function to do is take the second value and this thing values out of the initial list, right? Or at least return a list. It's not going to take it out. It's just going to basically build a new list with those items removed, right? So let's here. We'll do if result it's not equal to, oh, we'd have to build a new, let's do this. Result, we'll test the first bit, right? So the first one would be, we can do length. So the length should be 2. That would be a good test. Result dot length. No, okay. Length result is equal to 2, I think. We'll do t dot error the filtered the list has an incorrect number of items. So that's our first test. That'll help us get things working here. Now, if we're following TDD, I'll show you where this can mess up some things, right? So let's say with TDD, you're supposed to write this now so that it just meets the requirement, right? So I could do something crazy, for example, like, let's see here, get this fixed. This needs to be an array of strings. So we'll create our new return list, or return items, and we'll make that a string array like this, or string slice is what it'll be. And then we want to go through, so key value in the range of, items, or no, in the range of list. And I'm going to call this ignore items, or we'll call it, it should be ignore list. In the list, yep, okay. So to go through each item and return a key, the numerical key will be 0, 1, 2, etc. And then the value will be the actual value in that particular array, right? Or within the array. So in this situation, we'll go with, let's see here, if, we kind of need a sub function that'll return is a thing in this list or not, right? So that's actually what we're doing, right? Or is it not? No, we're writing already a more complex function. And there's a recursive element to this function that needs to be done, which is the check that something is in something. So let's put in here if value is, we need to do a list, for loop through it. So key value, nope, we need to do different ones. Key ignore list, key ignore value in range of ignore list. Okay. So if v is equal to key ignore list value, let's see, we'll set up let's see, value exists. False. Whoops, we need to put that here, right? And then here we'll say if that's true, we'll say value exists equals true, right? Oh, whoops, we need to assign it to true. And then here we'll say if value exists. If it doesn't exist, then we want to append, we want to set the return list, return items, append the new items for that. So we'll add the value, the list item, right? And we don't really need the key here, so I'm going to underscore it to ignore that. Same thing with this one. We don't really need a key. We just need to compare the values and then add them to the list. And then here we need to return, return items. So here I've kind of done a poor, let's rename that. What is it, Shift F6, I think? Yep. So this items, let's call it remaining items. Remaining items. There. So theoretically, big theoretically, because I know I always write code perfect the first time, but theoretically that should work. Let's see. No. So how many items do we end up with? So I could debug, but let's throw in this. I don't want to use the advanced debugging or anything at the moment. I just want to show, like, what do we got here? Let's try that. So if we go look at our, what is it, run, we click on that and it'll say first value, another value. So first value, another value. So that is correct, right? First value, another value. My function works. My test is incorrect. So what is wrong with my test now? If I look at this, say filter, ignore list, list, ignore these items, da 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 da. The question is, what is happening with this count? So let's do this. Let's print out format.println or print. Actually, yeah, let's use printf. So the items count, put that in, and then resulting list, and we'll do that, and then we can put in length result, see what that is, and then print out the result itself, and let's see what we get. Items count 2. Okay, now I'm, uh-oh, what did I do? List, items count is 2. Resulting list is first value, another value, which is correct. So why does it say that 2 is not the correct result here? Oh, maybe. Flip that. No, yeah, that's not right. Oh yeah. Yeah, it is a number then. It is int compared to an int. Of course, it's type safe language, right? Go, it's type safe language. So what is the deal? What is messing me up? 2. Items count 2, resulting list. First value, another value. Well, here's what I could do. Let's make this test this. Let's say result 1 we know will be first value, right? Let's see if that works. Oh, let's do this. Format print line. Say result 0. Oh, first value right here. And then item 1. Whoops. Come back here. Oh, just run it again. Another value. First value, another value. Let's add a little easier to read thing here. So we have two values. We have two count. And for some reason, my result... I am being an idiot. Of course, I was saying is 2 equal to 2. Yes, it is. So we'll say length, result, not equals to 2. Duh, right? So I actually had the function right. I just had the testing the wrong way, and I flipped it in my own brain. It's that dyslexia kicking my ass. So let's do that. And there we go. So now we have a filter ignore list. So that flips around two things. Let's move that over to our awesome lib. Okay. That looks good. So now we have all sorts of, we're adding functions. So what should we do now? Let's do another one. This one, what I'm going to do is, let's take a string with commas, just like I was talking about a little earlier. We'll take a string with commas, comma-separated list effectively, and then we'll split it out and make that string, turn that string into an array with pertinent items in each of the array elements. So, go back to the test, and let's say func test, build array from string, from CSV. That's what we'll do. CSV standing for comma separated values. Here we go. Var list. Go with this. And then var string. Oh wait. The CSV. There we go. All right. And then another way you can do this, we could just go ahead and say value 1, 2, 3, 7, 6, another value, right? So and then get in here. If we go back and look what this says, since string is knocked out, what it's saying is delete type because you don't need it. Since I'm assigning it to string value, Go knows that that's a string value. All right, so then let's do list, yes. And then result will be the built list that we want. Actually, let's do this. There we go. Result, build array from CSV. So this will be a string. Oh, wait, whoops. The CSV, comma, separated file, or values, and then string. Oh wait, no. I'm just calling it. So then what we want to have is if result dot first value is not equal to, was it value 1, and t.error, the first value is not correct, right? And let's do a redundant test here, or not a redundant test, but an additional test in the test to test for cases within the overall function. So we'll say if result, we'll do a length count on this one too. Result is not equal to, what do we have? 1, 2, 3, 4, 5, 6 values. We'll want to throw an error on that one too. So t.error, the returned array does not have the appropriate values. Oops, number of values. And then let's get some other ones in here for this. So we'll expect one, 2, 3, 4. We'll write a test for every one of the values, right? If result 4, 5, yes, 4, 5. That'll actually be 6 because we start with 0. And what will that be? That'll be 2. This will be 3. And then 7, 6, and then another value. The second value is not correct. The third value is not correct. The fourth value is not correct. The fifth value is not correct. And then the sixth. And since we count them as humans numerically from 1, I'm doing this. But of course, in programming, most arrays start from 0. The indexes start from 0. C#, Go, Java, C++. I don't know of any that actually start from 1. Which maybe Pascal or something. Anyway, just know most of these things in most languages, most software languages, start with 0. But we count from 1. So we'll always be off by 1. Thus, one of the silly things, which Digital Drummer mentioned earlier, computer programming, always off by 1. We've done it to ourselves because we start all the indexes with 0, even though we count from 1. Coffee. Burning my face off. Okay, so we got all that in there. Now I'm going to implement this create function. And it has this, which is going to be a string. And then we're going to return an string array, array of strings. And then, so let's create a var, and we'll call it the result for now. Just to get a bunch of broken stuff and to get a successful build so we can do TDD or whatever. And we'll just return the result. Okay, there we go. So let's run this test and see it blow up a bunch. There we go. So it blew up, and I wanted to say undefined. Oh yeah, because I didn't rename my. There we go. So now our deal is correct. So let's run that. And it died on index out of range, index out of range. So it broke because, again, Go is strongly typed. So it knows when, like in this build, it would know what this value is going to be. It starts out at a thing and it's not that value. So we had a panic. So not just a fail, but an outright panic, and there's the rest of the panic of the breakage, right? So let's make this do some stuff, because that's, as far as I'm concerned, that's a red. That's a breaking build, a breaking test. So it follows TDD practice. Straight up broke. So first things first, let's get our string. And it's pretty easy to kind of cheat on this functionality because Go gives us a beautiful element right off the bat. And I barely have to do anything in here. I can simply do string dot split, and then we're going to give it the string, right? And then the separator, boom, comma. Look at that. Magic craziness. Now, I'm going to show you another thing, though, that I like about this functionality. See, I don't even need this because I don't have to build anything. The builder is already included in there. So let's see what we get. Look at that magic. Boom. That entire test just passed. Right? Now, let's break it. This too is a comma separated list, but it has spaces in it now. Breaks. So first value is incorrect, third value is incorrect, sixth value is incorrect because it has spaces. Another cool functionality. Let's see, what is it? Strings.trim space. Literally the function we want. Okay, there we go. So what is this fussing about? Cannot use this on this. Oh, of course. Of course. What am I thinking? So now where we need to use this is we need to actually get some values in here. So var let's see here, split values is actually going to be the strings dot split, right? Values, get that comma separator in there. So that's going to give us that crazy one. And then we want to go through each of those values. Oh, no, we don't want to do that. We want to do, I think we're going to have to do that. We're going to have to build it. So for, again, key value in the range of split values, we'll call it cleaned up results. Here's our string array. So cleaned up results, split values. And we get that going on. So then we'll do cleaned up results equals append, add it to the cleaned up results, the value of strings dot trim space off of split values. Oh, what's it fussing about now? Oh, not split values, not all of the split values, the specific value that we're going through. We need to add that back to this new array called cleaned up results, or slice as they call it in Go, slice. And then we're going to return that puppy. Whoops. You can see how quickly this gets complicated. So we have cleaned up results. So now, we'll go back here, and boom, we are now running. So pretty good stuff, right? And again, let's put this refactor, move it to our file of functionality. All right, what else should we build? Anybody got any homework? See, I did that like a stream or two ago where I started doing somebody's homework. Oh, either way, just a few tidbits here in the trailing end of this. I'm going to lean to the side and let's get the browser up here. We have been listening to, in the background, the one, the only, Ginger, badass band. They are from Ukraine. Emphasis America, not the Ukraine. It's just Ukraine. I know, English is weird when we refer to mono things like that. But yeah, anyway, they're from Ukraine. They're freaking awesome. I've seen them live. I even have some loud tidbits on my YouTube, which you should go follow me at. I even have, let's see, I'm going to pull it up. Check this out. I have a new path, youtube.com/channel/thrashing code is now the official path for my channel. There it is. Oh yeah, good old theme song. So yeah, go check it out. I got my little BetterBots theme going on up there too. Stuff I've been working on at work around data stacks and the Astra database. Another thing that you should check out, just go to astra.datastacks.com and that'll get you to the sign-in page. But also this stream, a little cleaned up, because I'm going to start cleaning them up before they go to YouTube, get a blog entry, some other things going with them, get a little bit more disciplined around my post-Twitch stream collateral here so that it's a little more useful. Because, yeah, when you watch it post-facto and you're not interacting, it's kind of boring to watch me fumble through certain things. So it's going to be a little cleaned up in that regard. Not like cleaned up language-wise, just cleaned up code-wise. So yeah, anybody and everybody go follow me there, etc., etc. And in the meantime, who should we go follow? That is the next big question, because twitch.tv/, oh wait, we don't need to do that, but just do this. And who's coding? Oh, we got James Montemagno, Tim Boudreau, R.W. Grimm, very grim. I don't know if y'all know him. He's pretty awesome. Always digging through a lot of open source. So, big open source developer. Don the developer. Oh, he's talking about being a developer. That's interesting, sort of, kind of. I mean, you know, if you want to do that. Then there's Cowlow Creation. Cowlow is super chill. Love Cowlow. Strager, I don't know exactly how he says this thing, but he's usually working on a lot of cool stuff. I believe mostly, does it say here? Twitch chat viewer for my stream, blah, 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 something, something. Yeah, there you go. Rust, C++, C, JavaScript, HTML, Python. So it kind of bounces through some stuff, kind of like I do. Zorchenheimer is usually doing assembly for video games. Super badass. Super high level, nerd level stuff. There he is. Whoops, there he is. Right there. On stream with a nice skull shirt. Also, the Alt F4 stream. Super badass. Go check them out. They're great. The Primegian. This guy is super high energy. There he is. Yep. And then some other not programming related stuff, but Chainbrain here. Whoops. I don't ever know which one was what. Chainbrain. When he's listening to Unleash the Archers. Hell yeah. So that's that. And then, let's hear Bad Bunny. Oh, she argues about politics. She also does something else. But if you aren't super leftist, you'll get super pissed off if you go listen to her talk. Got a lot of, she's real trippy though. What else? Anyway, a lot of other good ones on here. Echo Hack, Jitspo, Program, all good streams. So who should we raid? All two of us. Let's go raid. Let's go raid Echo Hack. I haven't raided Echo Hack in forever. Oh, he's playing a video game. I don't want to raid when he's playing a video game. He's doing music. Oh, he's doing music for the app. He's writing code there. Oh, he's writing some Go. That's cool. You know what? We're gonna raid James. James is always a good sport. So let's go raid James. Oh, you want to raid Chainbrain? Actually, yeah, we're gonna raid Chainbrain. What the hell? Let's go get some metal. It's Friday.